Welcome students. Now today in this class I am going to solve questions on exercise 11.3 exercise. The first question is exercise 11.3. The first question is, in each of the following exercises, determine the direction cosine of the normal to the plane and distance from origin. And the first equation of plane is z equal to 2. Here z equal to 2. This can be written as 0x plus 0y plus z is equal to 2. Now this plane is in the form of normal form. Normal form of the plane is Lx plus My plus Nz is equal to d, where L, M, N are the direction cosine of normal to the plane. Any line which is perpendicular to the plane is having direction ratio L, M, N, and d is the distance from origin. Now compare this equation to this standard form. We can say that the direction cosine of normal to the plane is 0, 0, 1, 0, 0, 1, and this distance is perpendicular distance from origin. In this question, it is also asked that the distance from the origin. So here d is equal to distance from origin. Distance from origin is equal to 2. Now the next question B is x plus y plus z is equal to 1. If we write the vector equation of this plane, it will be r dot I cap plus j cap plus k cap is equal to 1. If we put r vector is equal to xi plus yj plus zk and take dot product of this vector to this vector, we will get this result, x plus y plus z. Now this vector is not the unit vector perpendicular to the plane. So first of all, we will divide this plane to both sides by under root 1 square plus 1 square plus 1 square. Coefficient of x, y, z is 1 here, divided by under root 1 square plus 1 square plus 1 square, that is root over 3. To both sides of the plane, we get 1 by root 3x plus 1 by root 3y plus 1 by root 3z is equal to 1 by root 3. Now, if we compare this equation to the standard one, that is Lx plus My plus Nz is equal to d. Here L, M, N are direction cosine of the normal to the plane. Then direction cosine of this plane, direction cosine of normal to the plane is 1 by root 3, 1 by root 3 and 1 by root 3, and perpendicular distance from origin if this plane is in the normal form, then this value will be the perpendicular distance from origin. Perpendicular distance from origin is here 1 by root 3. So this question is short. Direction cosine of normal to the plane is this, and perpendicular distance from origin is 1 by root 3. Now the next one is 2x, question number C, 2x plus 3y minus z is equal to 5. This implies, if we write the vector equation of this plane, we will get r dot 2y plus 3j minus k is equal to 5. Now this is not a unit vector. This vector is not a unit vector. Therefore, this plane is not in the form of normal form of the plane. To find the normal form of the plane, we must have this vector as unit vector. Dividing by coefficient of x, y, z, dividing by under root 2 square plus 3 square plus minus 1 square to both sides. We get the value of this is under root 4 plus 9 plus 1, that is 14, 2 by root 14 x plus 3 by root 14 y minus 1 by root 14 z is equal to 5 by root over 14. If we compare this equation by a scalar equation of plane in normal form, the direction cosine of normal to the plane is 2 by root 14, 3 by root 14 and minus 1 by root 14. And perpendicular distance from origin is 5 by root 14. Perpendicular distance from origin is 5 by root 14. Now the second question is find the vector equation of a plane. Find the vector equation of the plane which is at a distance of 7 units from origin, which is at the distance of 7 units from origin, and which is normal to vector which is normal to vector (3i plus 5j minus 6k). 3i plus 5j minus 6k. Any vector perpendicular to the plane, this is plane, and vector perpendicular to the plane is 3i plus 5j minus 6k. and the perpendicular distance from the origin is 7 units. If we write the equation of plane in normal form, that is r dot n cap is equal to d. Here n cap is the unit vector normal to the plane and d is the perpendicular distance from origin. Here d is given 7 unit, that is 7 unit, but n cap is not given. Unit vector perpendicular to the plane is not given. Simply a vector is given which is perpendicular to the plane. That let us suppose that vector is n vector is 3i plus 5j minus 6k. Now let us make this vector as a unit vector. Divide modulus of this vector is 3 square plus 5 square plus minus 6 square, that is 9 plus 25 plus 36. This is equal to 25 and 9, 34 and 36, that is 70. Now unit vector perpendicular to the plane is n vector divided by modulus of n. N vector is 3i plus 5j minus 6k. If we divide it by root over 70, that is modulus of vector n, this will become 3 by root 70i, 5 by root 70j and 6 by root 70k. Now we get the unit vector perpendicular to the plane. Putting this value vector n and d in the equation 1, we get the required equation of plane, that is r dot 3 by root over 70 I cap plus 5 by root over 70 j cap minus 6 by root over 70 k cap is equal to d, and d is 7. This is the required equation of plane. Now the next equation is the next question is find the Cartesian equation of the plane. Find the Cartesian equation of plane in the following cases. Vector equation of the plane is given and we have to convert the given vector equation into a Cartesian equation. First question is r dot vector r dot I plus j minus k is equal to 2. Now r is any general point on the plane. If we put vector r as xi vector plus yj vector plus zk vector dot I plus j minus k is equal to 2. Take the dot product of these two vectors. We get a1 a2, that is x plus y minus z is equal to 2. This is the required Cartesian equation of the plane. I think no need to solve other questions. Similarly, we can put vector r xi plus yj plus zk and taking dot product, we get the required result. Now question 4 is in the following cases In the following cases, find the coordinate of find the coordinates of foot of perpendicular drawn from the origin. And the first equation of the plane 2x plus 3y plus 4z minus 12 is equal to 0. Now the question is, let us suppose that this is a plane and this is the origin. A perpendicular is drawn from the origin to the plane, and this perpendicular meet the plane at point P. This point P is the foot of perpendicular from origin to this plane, and we have to find the coordinate of point P. Now this plane can be written as 2x plus 3y plus 4z is equal to 12. Here 2, 3, 4 is the direction ratio of any line which is perpendicular to the plane. Direction ratio of any line which is perpendicular to the plane is 3, 4, and this line which is passing through origin and perpendicular to the plane is also perpendicular to the plane. Therefore, direction ratio of this line OP is also 2, 3, 4. As we know that when two lines are parallel, their direction ratio will be same. Then equation of line OP is passing through point O and perpendicular to a point perpendicular to the plane at point P. Equation of line OP is x minus 0, direction ratio is 2, y minus 0, direction ratio second 3, and z minus 0 by 4. This is the equation of line OP. Any arbitrary point on this line is, if this is equal to r, then value of x will be 2r, value of y will be 3r, and value of z will be 4r. Any arbitrary point on this line is 2r, 3r and 4. Let us suppose that this arbitrary point is nothing but P. Then P will lie on the plane this point. If this point is the foot of perpendicular, then if point P, which is 2r, 3r, 4r, is foot of perpendicular, then this point will lie on this plane, that is 2, value of x we can put 2r, 3, value of y 3r, and coordinate 4 into z coordinate is 4r, is equal to 12. This is 4r plus 9r plus 16r is equal to 12. This is 29r is equal to 12. This implies r is equal to 12 by 29. Now the point P, which is the foot of perpendicular from origin to the plane, the coordinate of P is 2r and the value of r is 12 by 29, that is 24 by 29, 3r 36 by 29, and the z coordinate is 4r, that is 48 by 29. So in that way we can find the foot of perpendicular drawn from origin to any plane. Our second question is B, that is the 4B. The second question is 3y plus 4z minus 6 is equal to 0. Again, same process we are going to apply the same process. This is the plane, here is the origin, and a perpendicular is drawn from origin to the plane. If this perpendicular meets the plane at P, we have to find the coordinate of P. P is known as the foot of perpendicular. Now, the equation of the plane is 3y plus 4z is equal to 6. Direction ratio of any line perpendicular to the plane is 0. Here coefficient of x is 0, coefficient of y is 3, and coefficient of z is 4. Direction ratio of any line perpendicular to the plane is 0, 3, 4. That is 0, 3, 4. Direction ratio of perpendicular line to the plane. As this OP is also perpendicular to the plane, the direction ratio of OP, line OP, is same as 0, 3, 4. The equation of line OP, line passing through O and P, is x minus 0 by A, which is 0, y minus 0 by B, which is 3, and z minus z1, which is 0 by C, which is equal to 4. Any point on this line can be taken as any arbitrary point on this line is, if you put here equal to r, then the value of x, y, z, x will be 0, y will be 3r, and z is equal to 4r. So this is the arbitrary point on line OP. If this is point P, then this P will lie on the plane, and the equation of plane is, if this is foot of perpendicular, then it will be on the plane, plane 1, this is plane 1, and it will satisfy the given equation of plane. This implies 3 into y coordinate is here 4r, 3r plus 4z, y coordinate is z coordinate is 4r is equal to 6. This is 3r, this is 9r plus 16r is equal to 6. 25r is equal to 6. Therefore r is equal to 6 by 25. Now foot of perpendicular is P, and now the coordinate of P is 0, 3r. R is 6 by 25. 3r is 18 by 25, and 4r will be 24 by 25. In this way, we can find the foot of perpendicular drawn from origin to any plane. Some other questions are also asked about if this point is not origin, any point is given like 1, 2, 3, then you are told to find the image of the point and foot of perpendicular. You can apply the same formula here, same process to find the image of any point into any given plane. Thank you. Now question number 5 is find the vector and Cartesian equation of plane passing through the point (1, 0, minus 2) and normal to the plane is I vector plus j vector plus k vector. We have to find the plane which passes through a given point 1, 0, minus 2, and a normal vector, a vector perpendicular to the plane is I plus j plus k. Let this is vector n. This point is given, hence the position vector of this point will be I minus 2k cap. Now, by using the formula r minus a dot n vector equal to 0, we can find the equation of the plane. This is r minus I vector is I minus 2k dot n vector is I plus j plus k vector is equal to 0. Now after simplification we can get r dot I plus j plus k minus I minus 2k dot I plus j plus k is equal to 0. This is r dot I plus j plus k vector minus, taking dot product of these two vectors, this is 1 minus 2 is equal to 0. Now r dot I plus j plus k vector minus of minus 1, that is plus 1 equal to 0. This is the vector equation of the plane. Now putting a vector R equal to xi plus yj plus zk and taking dot product with I plus j plus k, we will get x plus y plus z plus 1 is equal to 0, and this is the Cartesian equation of the plane. Sixth question is, find the equation of the plane that passes through first the points passing through the points 1 minus 1. Second point is 6 4 minus 5, and third point is minus 4 minus 2 and 3, minus 4 minus 2 and 3. Now by using the formula equation of plane passing through 3 points, the formula is x minus x1, y minus y1, and z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, and z3 minus z1 is equal to 0. This is the equation of the plane passing through 3 points. Now putting the value of x1, y1, z1, this is x1, y1, z1, this is x2, y2, z2, and x3, y3, z3. That this determinant will become x minus 1, y minus 1, and z plus 1. x2 minus x1, 6 minus 1, that is 5, 4 minus 1, that is 3, minus 5 plus 1, that is minus 4. x3 minus x1, minus 4 minus 1, that is minus 5, minus 2 minus 1, that is minus 3, and 3 minus of minus 1, that is 4, is equal to 0. After simplification, you can get the required result equation of plane. Here we can write R3 is R3 plus R2. R3 in third row, we are adding second row. This is x minus 1, y minus 1, and z plus 1. This is 5, 3, and minus 4. But here it is 0, 0, 0. Now this is equal to 0. 0 is equal to 0. Here we cannot find the equation of plane because all these 3 points are collinear. Here all the 3 points are collinear. We can say that points are collinear. So we can only get the equation of plane passing through 3 non-collinear points. In this question, question number B is passing through the point. Now the points are 1, 1, 0, 1, 2, 1, and minus 2, 2, minus 1, minus 2, 2, minus 1. Again, we have to use the same formula. that is equation of plane passing through 3 points x minus x1, y minus y1 and z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. This implies x minus, this is x1, y1, z1, x minus 1, y minus 1 and z minus 0. x2 minus x1, 1 minus 1 that is 0, 2 minus 1 that is 1, 1 minus 0 that is 1. x3 minus x1, minus 2 minus 1 that is minus 3, 1 minus 1 that is 0 and minus 1 minus 0 that is minus 1 is equal to 0. Now we can expand this determinant to obtain the equation of plane. Expanding along R1, this is x minus 1, 1 minus 1, 1 into minus 1 that is minus 1 minus 0 minus y minus 1 into 0 minus 1 0 minus 3 into 1 minus of minus 3 that is plus 3 plus z minus 0 that is z and this is 0 minus of minus 3 that is plus 3 is equal to 0. Now this is minus x plus 1 minus 3y plus 3 plus 3z is equal to 0. Minus x plus 1, this can be written as minus x minus 3y plus 3z and plus 4 is equal to 0. After simplification we can get x plus 3y minus 3z minus 4 equal to 0 and this is the required equation of the plane. Next question is find the intercept cut off by the plane 2x plus y minus z is equal to 5. Now we know that the intercept form of the plane is x by a plus y by b plus z by c is equal to 1. Now converting this equation into intercept form, 2x plus y minus z is equal to 5. Dividing by 5 we can get 2x by 5 plus y by 5 plus z by minus 5 is equal to 1. This can be written as x 5 by 2 plus y by 5 plus z by minus 5 is equal to 1. Now comparing with this standard equation, we can get x-intercept is 5 by 2, y-intercept is 5 and z-intercept is minus 5. X-intercept is 5, y-intercept is x-intercept is 5 by 2, y-intercept is 5 and z-intercept is minus 5. Next question 8 is question number 8 is find the equation of the plane. Find the equation of the plane with intercept on y-axis, intercept on y-axis is 3 and parallel to XOZ plane, XOZ plane. Now we know that equation of XOZ plane, XZ plane is y equal to 0. Equation of XZ plane, this is also known as XOZ plane, is y equal to 0, and any plane which is parallel to this plane is of the type equation of plane parallel to XOZ plane is y equal to k. This plane passes through as y intercept is 3, means this plane is passing through the point 0, 3, 0. By putting this point in this plane, we can get k equal to 3. Hence, equation of plane, required plane is y equal to 3. This is the required plane. Now the next question is that is 9. Find the equation of the plane through the intersection of the plane of the plane 3x minus y plus 2z minus 4 equal to 0 and x plus y plus z minus 2, x plus y plus z minus 2 is equal to 0, and passing through the point 2 to 1, 2 to 1. If this plane is lambda 1 and this plane is lambda 2, then equation of plane equation of plane passing through intersection of lambda 1 and lambda 2 is lambda 1 plus k lambda 2 is equal to 0. This plane is lambda 1. This implies 3x minus y plus 2z minus 4 plus k. Lambda 2 is x plus y plus z minus 2 is equal to 0. Now this plane passes through the point, this plane 1 passes through the point 2 to 1. By putting x equal to 2, y equal to 2, z equal to 1 here, we can get 6 minus 2 plus 2 minus 4 plus k. X is 2 plus 2, y is 2 and z is 1. Minus 2 is equal to 0. Here you can say plane 1 is passing through 2 to 1. This is 6 minus 2 4, that is 2 plus k into this is 3 is equal to 0. The value of k is minus 2 by 3. Now putting the value of k in equation 1, from 1 we can get 3x minus y plus 2z minus 4 minus 2 by 3 x plus y plus z minus 2 is equal to 0. After solving this equation, we can get 9x minus 2x, 9x minus 2x, that is 7x, minus 3y and minus 2y, that is minus 5y, 6z minus 2z, that is 4z, minus 12 and plus 4, minus 12 plus 4, that is minus 8 is equal to 0, and this is the required equation of plane 7x minus 5y plus 4z minus 8 is equal to 0. Thank you.